something deep beneath the Great Lakes just shifted, and scientists now warn the region could be unrecognizable within decades.
The Great Lakes region has been called a climate refuge, protected by cooler temperatures and sitting high above sea levels. The 5 lakes are surrounded by
the Great Lakes, that immense chain of inland seas stretching from the upper reaches of New York to the heart of Minnesota, have long been a symbol of stability and natural power. They hold about 20% of the world's fresh surface water, a lifeline for millions of people across the United States and Canada. For generations, these vast waters have been studied, mapped, and monitored so carefully that sudden surprises seem nearly impossible. Yet, in recent days, something deeply unusual has occurred beneath their calm surfaces, something that has scientists, environmental observers, and local residents on edge. Without warning, the Great Lakes began to show strange, almost unprecedented activity that defies easy explanation. It started quietly, ripples, temperature shifts, and odd acoustic readings, but soon escalated into a series of events that suggest something much larger may be stirring beneath the waters. Before we start, hit the like and subscribe buttons for more exclusive news. It began in Lake Superior, the largest and deepest of the 5. Known for its cold, unyielding depths, Superior has always been the most enigmatic of the lakes. Sensors placed along its basin began transmitting irregular seismic vibrations late one night, patterns that didn't fit the usual geological signatures of minor tremors or shifting sediment. At first, experts thought it might be equipment malfunction. But when several independent monitoring stations across both the US and Canadian sides of the lake registered identical anomalies, the situation took on an entirely different tone. The vibrations were rhythmic, almost pulsing, as though the lake itself was breathing in long, slow intervals. This wasn't the usual kind of activity one would expect from a tectonically stable region. The Great Lakes sit far from major fault zones, and any seismic activity here is typically mild and infrequent. The fact that these signals were not only strong but sustained sent ripples of concern across research institutions. Within a few hours, similar disturbances began to appear in the other lakes. Lake Michigan recorded sudden temperature inversions, where the normally cold, dense bottom layers became unexpectedly warm. Buoys equipped with thermistors logged the event in real time, showing drastic temperature swings in less than 30 minutes. This was not a natural fluctuation that could be explained by weather patterns or currents. It appeared to be an internal force reshaping the lake's stratification from within. Fishermen near the southern shores reported seeing strange rolling waves that came without wind. These were not the rhythmic pushes of a storm surge, but chaotic undulations that seemed to come from below, as though something was displacing water deep under the surface. Lake Huron, the quiet middle sibling between Michigan and Superior, began producing faint, low-frequency hums that could be detected by sonar arrays miles away. Ships passing through the area reported interference with their navigational instruments. Some crew members described feeling an uneasy vibration underfoot, as if the lakebed itself was moving. Satellite imagery taken the following morning revealed subtle, circular patterns forming across portions of the water's surface, massive symmetrical rings spanning hundreds of meters. They resembled the ice circles that sometimes appear in winter due to eddies, except these were seen in the middle of open, warm water in autumn. Their formation was almost too perfect, geometrically precise in a way nature seldom produces without guidance. The first scientists to respond were hydrologists and limnologists, trained in understanding how inland water systems behave. But as data continued pouring in from remote sensors, the anomaly began to attract attention from seismologists, atmospheric scientists, and even military analysts. It was the suddenness of it all that alarmed them most. The Great Lakes are some of the most studied bodies of water on Earth. Thousands of sensors track temperature, chemical composition, and even minor biological shifts. Yet none of these networks had predicted what was happening. One researcher described it as watching a heartbeat start in a place that shouldn't have one. The strange pulses seemed to move in waves, traveling between lakes in a sequence that mirrored the natural drainage pattern. From Superior down through Huron, Michigan, Erie, and finally Ontario. This pattern hinted at some kind of interconnected mechanism linking them all, as though the lakes were communicating through deep subterranean channels that scientists hadn't fully mapped. Speculation ran wild. Some suspected volcanic gas releases from ancient faults buried deep beneath the glacial sediments. Others suggested it might be magnetic disturbances from the Earth's core subtly shifting the crustal plate beneath the region. A few theorized it could be resonance effects from human activity, underground detonations, industrial drilling, or powerful electromagnetic testing. But each theory crumbled under scrutiny. The sensors picked up no chemical signatures consistent with gas. The magnetic field remained stable, and the region showed no signs of human interference large enough to trigger such a synchronized event. It was as though something far beneath the Earth had awakened, sending out vibrations that passed through water, rock, and sediment alike. The implications of these anomalies are staggering. The Great Lakes aren't just environmental treasures, they're economic and ecological keystones. Any shift in their physical or chemical balance could have cascading effects on everything from local climates to food chains. The sudden warming at the bottom of Lake Michigan, for instance, could release trapped methane pockets buried in the sediment, altering atmospheric conditions around the Midwest. The rhythmic vibrations in Lake Superior might destabilize long-buried glacial rock layers, potentially creating underwater landslides capable of generating inland tsunamis. Even the faint hums recorded in Lake Huron suggest a form of resonance that could disrupt aquatic life dependent on sonar-like navigation. Each lake, connected by a complex web of rivers and straits, could amplify the disturbances of the others, turning the entire Great Lakes basin into a vast, oscillating system teetering on the edge of instability. Communities around the lakes began noticing subtler changes. Birds that usually migrated along predictable flyways started diverting from their normal routes. Fish that typically stayed near the shallows were found dead or disoriented near deeper channels. The air above certain shorelines took on a faint metallic scent, as if charged with static. Night skies glowed faintly with unfamiliar hues, a shimmering aurora-like light even when geomagnetic conditions were quiet. To many residents, these were small signs that the natural equilibrium was shifting in ways no one fully understood. Farmers near Lake Erie began reporting that their wells, fed by groundwater connected to the lake's hydrological system, were producing bubbles and faint tremors. What was happening under the water seemed to be echoing through the land itself. Scientists rushed to collect data before the phenomenon subsided. Autonomous submersibles were deployed, diving deep into the frigid depths to capture sonar readings and sediment samples. What they found added yet another layer of mystery. At certain depths, the submersible's instruments detected vast columns of suspended particulate matter, sediment stirred up in patterns too deliberate to be random. Some plumes extended vertically for hundreds of feet, moving slowly like undersea smoke. The chemical analysis of these sediments showed elevated levels of rare minerals not typically found in the lake beds, as though materials from much deeper geological strata had been forced upward. Even more puzzling, sonar imaging revealed fleeting shapes near the lake floors, large dome-like protrusions that hadn't been there in prior scans. Within hours, some of these structures vanished, as if they had collapsed or been reabsorbed into the sediment. This transient geological activity hinted at forces powerful enough to mold and unmake the terrain in real time. Lake Erie, the shallowest and warmest of the five, reacted differently. Instead of vibrations or temperature changes, it experienced sudden drops in water level along its western basin. Entire docks were left temporarily dry, only for the water to rush back with violent surges minutes later. These oscillations resembled seiches, standing waves caused by pressure changes or distant storms. But no such atmospheric events had occurred. The energy driving these water movements seemed to originate from within the lake rather than above it. Such spontaneous displacement of water carries profound implications for coastal stability and infrastructure. If these oscillations were to grow stronger or synchronize across multiple lakes, they could wreak havoc on ports, bridges, and power facilities lining their shores. Meanwhile, in Lake Ontario, the final link before the waters spill into the Atlantic, the disturbances appeared to manifest as magnetic irregularities. Research vessels equipped with magnetometers detected erratic fluctuations in local magnetic fields, strong enough to interfere with compass readings. Electronic navigation systems faltered, and drones mapping the shoreline began veering off course. Interestingly, these magnetic anomalies seemed to pulse in rhythm with the same frequency observed in the other lake's vibrations, reinforcing the theory that something vast and coordinated was underway. The possibility that the lakes were responding to a deep geophysical process, perhaps even one extending across continental scales, could not be dismissed. The public soon grew aware that something was amiss. News of unusual water patterns, disrupted shipping routes, and wildlife displacement spread quickly. However, officials were cautious about releasing details. With so many unknowns, they feared sparking panic or premature conclusions. Yet for many observers, the implications were impossible to ignore. The Great Lakes rest atop a region of ancient bedrock known as the Canadian Shield, one of the oldest and most stable geological formations on Earth. If something was capable of disturbing this stability, it meant forces of extraordinary magnitude were at play. Could it be that the crust beneath the lakes was shifting in ways that heralded a new phase of geological activity? Or was it something even more complex? Perhaps an interaction between the planet's magnetic field and the immense bodies of freshwater acting as natural amplifiers. For centuries, the lakes have been treated as passive receivers of nature's rhythms, filling, freezing, thawing, and evaporating in predictable cycles. But this event suggested they might also act as conduits, capable of transmitting energy through interconnected pathways deep below the surface. The water, in this sense, could be more than a reservoir. It could be a messenger, responding to planetary changes invisible to the human eye. When viewed from orbit, the synchronized pulses across the lakes looked eerily deliberate, like the heartbeat of a single massive organism. That image lingered in the minds of those studying the data, raising philosophical as well as scientific questions. Could Earth itself, in some subtle way, be signaling distress through its waters? As the disturbances continued intermittently, patterns began to emerge. Each wave of activity followed the lunar cycle, peaking around new moons when tidal forces are at their strongest. Yet the Great Lakes are far too small to experience significant tidal effects compared to the oceans. This correlation suggested that the gravitational pull of the moon might be interacting with something already unstable beneath the lakes. If a pocket of molten rock or pressurized gas existed deep within the crust, the rhythmic tug of the moon could be enough to agitate it, creating pulses that travel upward through water and rock alike. Such a scenario would mark the first indication of deep tectonic reawakening in the region in recorded history, a process that could reshape the landscape over centuries. Even within the scientific community, opinions diverged sharply. Some viewed the event as a geological anomaly, a rare but natural occurrence that would fade with time. Others saw it as a precursor to something far greater, perhaps the early tremors of a planetary shift tied to the planet's magnetic realignment or deep crustal movement. There were whispers among climatologists, too, that the unusual heat and pressure exchanges could hint at internal Earth systems compensating for imbalances caused by rapid climate change. The melting of northern ice sheets, after all, has been redistributing mass across the planet. Such redistribution can alter the planet's rotation slightly, influencing geophysical stress points in surprising ways. The Great Lakes, sitting atop a crucial continental hinge, might be absorbing some of this tension and expressing it through these strange, coordinated pulses. The emotional response from those living along the shores was a mixture of awe and fear. People who had spent their lives near these waters described an unsettling intuition, a sense that the lakes were no longer resting but watching. Some reported hearing faint sounds at night, a deep resonant hum that seemed to emanate from the horizon. Others felt slight ground vibrations even miles inland, lasting only seconds but unmistakably real. For the indigenous communities that have long viewed the Great Lakes as living entities, the phenomenon was interpreted through a spiritual lens. To them, the lakes were communicating, expressing discontent after centuries of environmental imbalance and human exploitation. Whether one approached it scientifically or spiritually, the feeling was the same. Something vast was stirring, and humanity was merely a witness. As data poured in, a clearer yet more unnerving picture began to form. Modeling software used by hydrodynamic researchers showed that the frequency and timing of the pulses aligned with deep pressure gradients beneath the lakes. It was as if energy was building up in the crust and being released through the water column in slow, rhythmic bursts. These bursts might be harmless at first glance, but their consistency suggested a continuing process rather than a one-time event. The question then became, How much energy was involved, and could it escalate? If the vibrations grew in amplitude, they might eventually destabilize portions of the lake beds, triggering underwater landslides or fissures. The sediments in some regions contain layers of ancient organic matter that, if disturbed, could release immense amounts of methane, a potent greenhouse gas that could further exacerbate global warming. In Lake Michigan's depths, a team operating remote submersibles detected faint plumes of gas rising from the lake bed. Though small, these emissions carried chemical signatures consistent with methane hydrates, ice-like compounds that store methane under pressure. Normally stable, such hydrates can become volatile if temperatures or pressures change suddenly. Their presence in a freshwater environment like the Great Lakes had long been considered minimal, yet here they were, reacting to some unseen catalyst. The idea that the lakes could be releasing long-trapped gases hinted at a chain reaction with both geological and climatic dimensions. If these emissions accelerated, they could alter the composition of the lake's ecosystems and influence weather patterns around the basin. The Great Lakes region already plays a critical role in moderating North America's climate. Even small shifts could produce far-reaching effects. Observers began to consider the possibility that what was happening was part of a larger Earth system adjustment. Across the globe, strange anomalies had been recorded in recent years: rising geothermal activity in unexpected locations, shifts in ocean currents, unexplained fluctuations in Earth's magnetic poles. Could the Great Lakes event be another manifestation of this broader planetary rebalancing? The lakes sit at a crossroad of continental plates, magnetic boundaries, and ancient glacial scars. Their waters might be amplifying the resonance of Earth's deeper convulsions, acting as giant sensors reflecting internal shifts we barely comprehend. If so, what appeared as a localized disturbance could, in fact, be an early warning of more global transformations yet to come. While experts continued to analyze every scrap of data, ordinary people turned their gaze to the lakes with newfound apprehension. The calm waters that once symbolized peace now seemed alive with unseen energy. Boats rocked gently on still days. The air carried faint electric tinges, and even the waves breaking on the shore seemed to move with a strange rhythm. Nature, it seemed, was sending signals that human perception could barely interpret. The Great Lakes have endured for millennia, carved by glaciers, fed by rivers, and bound by rock. But never before had they shown such simultaneous, inexplicable motion. Whether the cause lies in geology, magnetism, or something more mysterious, the implications stretch far beyond science. They touch the fundamental relationship between Earth and its inhabitants, a reminder that beneath the veneer of normalcy, the planet is alive and constantly changing. If this energy continues to build, it may redefine humanity's understanding of stability. The Great Lakes, long considered ancient and immutable, now stand as a symbol of nature's unpredictability. Their waters, deep and dark, conceal more than physical mysteries. They hold echoes of the planet's memory, responding to forces that reach from the molten core to the outer atmosphere. What has begun beneath those waves could be an early whisper of Earth's deeper restlessness, a pulse from the heart of the planet itself, reminding all who live by those shores that nothing in nature remains still forever. As days passed, the pulse beneath the Great Lakes continued with subtle variations. As if testing the limits of equilibrium, instruments recorded faint fluctuations in barometric pressure that corresponded precisely with underwater tremors, suggesting a dialogue between air and water, sky and depth. Strange bioluminescent streaks appeared in some northern coves, light-emitting organisms reacting to shifts in electromagnetic fields. The lake's surfaces grew eerily still before dawn, holding an unnatural silence that seemed to anticipate movement. Researchers noted that these moments of calm carried their own energy, a charged stillness that defied explanation. Every ripple and hum now carried weight, every subtle vibration a potential clue. The Great Lakes, once viewed merely as geographic fixtures, were revealing a hidden dynamism, an ancient intelligence woven through water and stone. What began as an anomaly had become a revelation. The realization that even the world's oldest waters can awaken, reminding humanity of nature's unfathomable depth. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us? What are your thoughts on the strange Great Lakes activity recently? We want to hear from you. Thank you for watching and see you next time.